Hello everyone. Today we are going through part B of second PUC mathematics model question paper. This part B has 9 questions. You have to answer any 6 questions. Each question carries 2 marks. Okay. So 21st question, show that sine inverse of 2x root 1 minus x square is equal to 2 into sine inverse x. Range of x minus 1 by root 2 less than or equal to x less than or equal to 1 by root 2. Okay. So here look at the LHS, sine inverse of 2x root of 1 minus x square. We have to derive it, right? So here what is our aim? Our aim is to remove this sine inverse. Okay. To remove sine inverse, here we have to bring sine here, right? So according to that we have to substitute the x. Okay, so what is x? See, if we substitute, you just first of all you just calculate it in your mind that if we substitute x is equal to sine theta, what we will get? See, 1 minus sine square theta, that is cos square theta, square root of cos square theta, cos theta, right? Cos theta, here sine theta. 2 sine theta cos theta. We will get 2 sine theta cos theta. We have an identity 2 sine theta cos theta is equal to sine 2 theta. Right? See here, if we substitute x is equal to sine theta, we will get sine 2 theta, sine inverse of sine 2 theta. So sine inverse of sine 2 theta is nothing but 2 theta, right? So here we have to substitute x is equal to sine theta. Okay? Put x is equal to sine theta, then sine inverse of, because here we have to remove this sine inverse, right? So sine inverse of, to remove sine inverse we have to bring sine here, right? So here 2 into sine theta root of 1 minus sine square theta. That is equal to sine inverse of 2 sine theta root of 1 minus sine square theta. 1 minus sine square theta is cos square theta. Square root of cos square theta is cos theta, right? Cos theta. That is equal to sine inverse of 2 sine theta cos theta is nothing but sine 2 theta. Okay, sine 2 theta. Okay, we know that sine inverse of sine x is equal to x, right? So sine inverse of sine 2 theta is 2 theta. So what is theta? See, we have put x is equal to sine theta. That implies theta is equal to sine inverse x, right? So here 2 into sine inverse x. Hence it is proved. Show that the points A of A B plus C, B of B C plus A, C of C A plus B are collinear using determinants. So here we have to show given points are collinear points. Collinear points means the points lying in the same line, right? So here using determinants we have to show these 3 points are collinear points. See, these 3 points are collinear points, means 3 points lying in the same line. Okay, and here we have studied that using determinants how to find the area of triangle. Okay, and see, if 3 points are lying in the same line, there is no triangle, right? There is no triangle. That means area of the triangle is 0. Okay, suppose one point is here. Okay, see, it can form a triangle, right? Therefore, here to show 3 points are collinear points, we have to show area of the triangle of these 3 points is 0. Okay, so here using determinants, let's show these 3 points are collinear points. Okay, for that area of the triangle. What is the area of the triangle? Area of triangle. Area of the triangle is equal to determinant. See, these 3 points x1, y1, x2, y2, x3, y3. Right? So, area of the triangle is equal to determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. Right? So, here A, B plus C, 1, B, C plus A, 1, C, a plus b 1. Right? So here we have to show it is equal to 0. To show given points are collinear points. Okay. So let's expand this determinant. A into, that is c plus a minus of a plus b, that is minus a minus b. Okay, minus b plus c into b minus c plus 1 into b into a plus b minus c into a plus c. Okay, that is equal to, simplify, here a minus cancelled, so a into c minus b. Okay, here minus of b plus c into b minus c, that is b square minus c square. So minus of b square minus c square, that is minus b square plus c square. Right? See, you should be careful about plus and minus. Okay, plus 1 into, here b into a plus b, b into a plus b minus c into a plus c. Okay, that is ac minus ab minus b square plus c square plus ab plus b square minus ac minus c square. Okay, minus b square plus b square cancelled, plus c square minus c square cancelled, ac minus ac cancelled, minus ab plus ab cancelled. That is, it is equal to 0. Okay, so here we have got area of the triangle of given 3 points is 0. That means there is no triangle. That means these 3 points are lying in the same line. Okay, so given points are collinear points. Next is very simple question. Find dy by dx if 2x plus 3y is equal to sin x. Directly we can differentiate it on both sides. Okay, so 2x plus 3y is equal to sin x. We have to find dy by dx. So find the derivative. Derivative of 2x is 2 plus derivative of 3y. 3 into derivative of y is dy by dx is equal to derivative of sin x is cos x. We need to find dy by dx, right? So take these 2 here. So 3 dy by dx is equal to cos x minus 2. Therefore dy by dx is equal to cos x minus 2 divided by 3. Find the local maximum value of the function g of x is equal to x cube minus 3x. Okay, to find the local maximum value of the function, first of all we have to find the critical points, right? So here to find the critical points we need to find g dash of x, derivative of g of x. Okay, g dash of x is equal to 3x square minus 3. Okay, to find the critical points g dash of x is equal to 0. That implies 3x square minus 3 is equal to 0. That implies x square, take 3 there. Okay, so x square is equal to 1. That implies x is equal to plus or minus 1. So what are the critical points? X is equal to 1 and x is equal to minus 1. Okay, next let's find g double dash of x. G double dash of x is equal to 6x. Right? Now when x is equal to 1, what is g double dash of x? Is equal to, substitute x is equal to 1, 6. That is greater than 0. That means g of x is minimum, right? If g double dash of x is greater than 0 means it is minimum at x is equal to 1. Okay. So here g double dash g of x is minimum at x is equal to 1. And substitute x is equal to, next critical point is minus 1, right? So x is equal to 1 and x is equal to minus 1 are critical points. Okay, so next substitute x is equal to minus 1. So g double dash of x is equal to 6 into minus 1, 6 less than 0 when x is equal to minus 1. Okay, so let g double dash of x is less than 0 means g of x is maximum at x is equal to minus 1. So g of x is maximum at x is equal to minus 1. So here what is the question? We have to find the local maximum value of the function. Okay, so here we have got g of x is maximum at x is equal to minus 1. Now substitute this x is equal to minus 1 in this g of x, that is the maximum value. Okay, here we have got g of x is maximum at x is equal to minus 1. Therefore, maximum value of the function is maximum value of g of x is equal to, substitute x is equal to minus 1. So minus 1 cube minus 3 into minus 1, that is equal to minus 1 plus 3, that is equal to 2. So 2 is the answer. Evaluate integral sine 3x cos 4x dx. Integrand is of the form sine A cos B, right? Here to integrate such functions we have to apply trigonometric identities. Say we have an identity 2 sine A cos B is equal to sine A plus B plus sine A minus B, right? Okay, so here it is of the form sine A cos B, right? So take 2 here. So sine A cos B is equal to 1 by 2 sine A plus B plus sine A minus B. Then here A is equal to 3x, B is equal to 4x, right? So sine 3x cos 4x is equal to 1 by 2 into 3x plus 4x, 7x, that is 1 by 2 into sine 7x plus sine A minus B, that is 3x minus 4x, that is minus x. So sine of minus x minus sine x. Okay, so let's substitute it here. So integral sine 3x cos 4x dx, that is equal to integral sine 3x cos 4x is equal to 1 by 2 into sine 7x minus sine x dx. Now we can integrate it very easily, right? That is equal to 1 by 2 into integral of sine 7x. Integral of sine x is minus cos x, right? Integral of sine x is minus cos x. Then what is integral of sine 7x? Minus cos 7x divided by 7. Okay? Minus integral of sine x is minus cos x, minus minus become plus, plus cos x plus c. Find the general solution of the differential equation y dx minus x dy divided by y is equal to 0. So here we have to find the solution of this given differential equation. So first of all, let's split it. Y dx divided by y minus x dy divided by y is equal to 0. Okay, that implies y cancelled, dx minus x by y dy is equal to 0. Take this one right side. This implies dx is equal to x by y dy, right? That implies take x this side so that we can apply variable separable method, right? So take x right side, sorry left side. So dx divided by x is equal to dy by y. Now integrating on both sides, dx divided by x is equal to integral dy by y. That is equal to, that implies integral of 1 by x with respect to x. 1 by x dx is log x, right? So log x is equal to log y. 1 by y dy is log y, and take constant as log c. Okay. That implies log x is equal to log y plus log x. It is of the form log x plus log y, that is log x into y. So log y into c. That implies x is equal to yc. It is the general solution. Next question is, find modulus of vector x if for a unit vector, vector a, vector x minus vector a dot vector x plus vector a is equal to 50. It is given that vector a is a unit vector. Okay, that means its magnitude is 1. That is modulus of vector a is equal to 1. Modulus of vector a is equal to 1. Why? Because it is given that vector a is a unit vector. Okay. Now, vector x minus vector a dot vector x plus vector a is equal to 50. So here x minus a into x minus b, x minus a into x plus a, that is x square minus a square. In vector, here we can write modulus of vector x whole square minus modulus of vector a whole square. Okay, vector x minus vector a dot vector x plus vector a, that is equal to modulus of vector x square minus modulus of vector a square. Okay, so that is dot product of two vectors is a scalar, right? Is equal to 50. Now modulus of vector x whole square is equal to, okay, substitute modulus vector a, that is 1. So 1 square is 1 is equal to 50. We need to find this one, right? So modulus of vector x whole square is equal to, take 1 here, that is 15 plus 1, 16. That implies modulus of vector x is equal to square root of 16, that is plus or minus 4, but it is since it is modulus, it is always plus, right? So positive. So it is modulus of vector x is equal to 4. Find the equation of the line in vector form that passes through the point with the position vector 2i minus j plus 4k and is in the direction I plus 2j minus k. Here, see, in three-dimensional geometry we learned that equation of a line passing through a point and the parallel vector are given is vector r is equal to vector a plus lambda vector b. Okay, here what is vector a? Is the position vector. Okay, and vector b is the parallel vector. See, read this question carefully. Here it is given that passes through the point with the position vector. So what is the point? 2 minus 1, 4. Okay, here position vector is given and is in the direction I plus 2j minus k. That is, it is in the same direction. That means parallel vector. So here position vector and parallel vector are given. So it is the equation of the line, vector form, in vector form. So vector r is equal to, vector a is nothing but position vector. Okay, position vector of the points. Okay, so here 2i minus j plus 4k plus lambda into vector b, that is parallel vector. Okay, here it is the parallel vector I plus 2j, I plus 2j minus k. That's all. So it is the required equation of the line in vector form. Prove that if E and F are independent events, so are the events E and F complement. F dash means F complement. So here it is given E and F are, if E and F are independent events, then we have to prove E and F dash are, that is F complement, are independent events. Here we know that if E and F are independent events, then probability of E intersection F is equal to probability of E into probability of F, right? Okay. Now here we have to prove probability of see, E and F complement are independent events means probability of E intersection F complement is equal to probability of E into probability of F complement. So this one we have to prove. Okay. So here E and F are independent events. Now we can write it as, say, suppose it is the event E, it is E and it is F. Okay. So it is nothing but E intersection F. Right. Now see this portion. It is nothing but E intersection F complement. Right? E intersection F complement, that is this one. Okay? See, it is nothing but F complement. Right? It is F complement. So here we can write it is E intersection F complement. Okay? So this portion is E intersection F complement. So we can write, see, probability of E intersection F complement as probability of, say, it is nothing but, this portion is nothing but probability of E, right? Probability of E minus E intersection F. Okay? This portion is total this E minus E intersection F, so that we will get this portion, right? So here this can be written as probability of E intersection F complement. See, it is E intersection F complement, right? So this probability of E intersection F complement, or here I will write E intersection F complement is nothing but E, okay, E minus E intersection F. That is probability of E minus probability of E intersection F. Okay. Probability of E intersection F complement, that is equal to probability of E minus probability of E intersection F. Okay. That is equal to, here we know what is probability of E intersection F. The probability of E into probability of F. So probability of E minus, here probability of E into probability of F. Okay. That is, see here in both terms probability of E is common, take it out. So probability of E into 1 minus probability of F. See, what is 1 minus probability of F? That is nothing but probability of F complement. Right? That is probability of E into probability of F complement. See, we have got probability of E intersection F complement is equal to probability of E into probability of F complement. That means it implies that E and F complement are independent events. Hence, E and F complement are independent events.